Hello students. Today I will be discussing on a very important chapter of class 10, that is chemical bonding. So let us see what's there. Now, before initiating chemical bonding, I would like to discuss about what is a bond. Now, a chemical bond can be defined as the force of attraction between any two atoms in a molecule to maintain stability. It means that the molecules attain stability by forming chemical bonds. And there are three types of bonds. We can see in the screen, it's electrovalent bonds, covalent bonds, and coordinate bonds. In this video, we will only be discussing about electrovalent bonds and covalent bonds. And since we will not be having much time, we won't be able to discuss about the coordinate bonds. So now, since we're talking about the atomic stability, now how do atoms attain stability? The stability of an atom depends upon whether or not their outermost shell is filled with electrons. Since by attaining that means that the atoms attain stability by attaining the noble gas configuration. Now, what is this noble gas configuration? It means that the atom will follow the octet or the duplet rule. Now, see, I have already mentioned what is an octet rule. According to the octet rule, an atom can be regarded as to be most stable when its valence shell is filled with 8 electrons, except for hydrogen and helium. So we can say that to attain a noble gas configuration, an atom have 8 electrons in its outermost shell. So we can say that an atom can attain stability by losing or gaining electrons by forming ionic or covalent bonds between them. Okay, so let us now go to an example. The first one is the electrovalent or ionic bond. Now, ionic bond or electrovalent bond takes place between a metal and a non-metal, always. Now, the metals always loses electron and they always contain 1, 2 or 3 electrons in their outermost shell. Non-metals, they gain electron and their outermost shell contains 4, 5, 6, 7 electrons. Now, remember, the metals lose electron as they contain 1 to 2, 3 electrons in their outermost shell. And since metals are having very small number of electrons, it will be convenient for them to give up 1 to 2 electrons to attain an octet. Similarly, for the non-metals also, it will be more convenient for them to accept electrons to fill up the octet. And therefore, a metal donates electron and a non-metal accepts electron, forming an ionic bond. Ionic bond means a bond is formed between two ions, a cation and an anion. So here we will be looking at this electrovalent bond by using the example of NaCl, formation of NaCl. So the electronic configuration of sodium is 281. It's a metal, and the electronic configuration of chlorine is 287. So it's a non-metal. And so what will happen? The sodium metal will donate 1 electron from its valence shell to chlorine to fill up the octet. So we can see here that this Na, sodium, has donated 1 electron from its valence shell to chlorine atom to attain the electronic configuration, the stable configuration 2 and 8, and it has become Na+. Similarly, chlorine has accepted 1 electron and has become 288. Previously it was 287, so it has become 288 and has become Cl-, Na+ and Cl-. So this is how an electrovalent bond is formed between Na+ and Cl-. Similar examples can be seen in magnesium chloride. magnesium chloride formation. So magnesium has an atomic number 12, its electronic configuration is 282, and chlorine's atomic number is 17 and its electronic configuration is 287. So it's very much evident that this magnesium will be donating 2 of its electron to each of these chlorine atoms. MgCl2, so it has got 2 chlorine atoms. So magnesium will be donating 1 electron to each of these chlorine atoms. And chlorine atoms have 7 electrons in its valence shell. So each of the atoms will be accepting 1 electron from the magnesium atom and will attain a octet. So it will become 288. You can easily see in this diagram that this magnesium is donating 2 electrons and it is becoming Mg2 plus, whereas each of the Cl atoms are collecting or gaining 1 electron, becoming Cl minus each. So this is how an MgCl2 is formed. Now let us go into covalent bonding. Now, covalent bonding is a bit different from electrovalent bonding. Electrovalent bonding is like you have ordered a pizza and you don't have the appetite to eat it, so you give it away to your friend since you are not hungry. And what's a covalent bond? Covalent bond is like both of you are hungry and you are sharing a pizza. So it's mutual sharing of electrons. And please remember, covalent bonding always takes place between a nonmetal and a nonmetal. So let us first see the example of the formation of an H2 molecule, that is 2 hydrogen atoms. So we can see that hydrogen has 1 electron in its outer shell, and so it requires 1 more electron to justify the duplet rule. So each of the hydrogen atoms will be sharing 1 electron of their own with the other hydrogen atoms. Thus each of them are having now 2 electrons in their last shell. So this is how a covalent bonding is formed between 2 hydrogen atoms. And please remember, since 1 electron from each of the hydrogen atoms has been shared, a single bond is formed. Now we will look at the example of the formation of O2 molecule where a double bond has been formed. So we can see clearly that in the formation of O2 molecule, the last shell of the oxygen atom is having 6 electrons. So it needs 2 more electrons to complete its octet. So what will it do? Both the oxygen atom will share a pair of electrons with each other. So here they are sharing 2 pair of electrons, 1 pair of electrons each. So that is why the bond that has been formed here is a double bond, and it's a covalent bond. Let us go on to the next slide. Similar covalent bonding can be seen in the formation of N2 molecules, but here a triple bond is formed. We can see the electronic configuration of N is 2 and 5. That means it is having 5 electrons in its last shell and hence require 3 more to attain the octet. So each of the nitrogen atoms, they share 3 electrons each with each other to complete the octet. You can see in the slide, previously it was 2 and 5 electronic configuration. After sharing, the electronic configuration of both the atoms are becoming 2 and 8. Thus the octet rule is justified. So here we can see a triple bond has been formed. Similar type of covalent bonding formation takes place in case of methane, ammonia, and water. So what happens in methane? Carbon atom has got 4 electrons in its last shell. So it shares 4 of its electron with 4 hydrogen atoms, and each of the 4 hydrogen atoms share 1 electrons each. So this is how the carbon atom is gaining is having its octet filled. Similarly, hydrogen is also having its duplet filled. So we can see how the CH4 bonding has been formed. Similar case happens for ammonia and water as well. So this is how an electrovalent bond and a covalent bond occurs. Here are some tricky questions, but we will be answering this question in our live classes. I hope you enjoyed. Thank you.